Everyone, welcome to Vishesh Educational Videos. So in this video, I am explaining about second normal form in relational algebra. Okay, if you are not subscribed to my channel, please subscribe to my channel. To get the notification of my new videos, please click the bell icon. So let me begin the explanation of second normal form. So before explaining what is a second normal form, I need you to understand some basics first. So once you are familiar with the basics, we can easily move on to the explanation of second normal form. So first I will explain some basics, then we can move on to the explanation of second normal form. So now, what is normalization? First we need to understand why we need normal forms, right? So normalization is the process of reorganizing data in a database. So you know that what is a database? So database is nothing but it is a place to store a data, right? So we need to store data in a database in such a way that it should meet two requirements. Why we have to store data like that? Because it is going to make our job easier. So what are those requirements? First is, whenever you store the data, you should store the data in such a way that there is no redundancy of data. Now you can ask a question, what is redundancy? Redundancy means storing the same data in different places. It should not be like that, because it's going to waste the storage space. So to avoid that, right, so I need to store the data in such a way that all the data is stored in only one place. Same data can't be stored in different places. For example, if I want to store the employee information, I should store the employee information in such a way that, for example, first I store the employee information in accounts department, assume like that. So same data that is in the accounts department can be used by other departments. No need to store the same data in other departments like transport department, right? Such like that. So instead of storing the data in accounts department also, transport department also, you can store the data in only one place, thereby other department can refer the data. So redundancy should be avoided. So and the second requirement is all the related data should be stored together. That means for example, if I want to make any changes to my data, for example, assume that I am changing the data related to employee in the accounts department. So once I change the data related to the employee in the accounts department, it should be automatically reflected in the transport department also. No need to change the data in every place, right? If I store the data, if I make the changes to the data, it should be automatically reflected. How we can achieve that piece? If we store all the data items that are related together, it should, right? If we store all the data items that are related together, we can achieve that dependencies, right? So that's why we need a normalization. So in this video, there are a lot of normalization techniques are there. So if you want to know more about first normal form, the link is in the description. You can go through it. So here in this video, I am concentrating only on the second normal form. So before explaining, again, you need to know some basics. So first of all, you need to know what is a relational database. So relational database means you are going to store the data in the form of tables. So you can see here, this is the example of a relational database. In this example, I am storing the employee information of a particular organization. Okay, so here how I am storing the information means I am storing the information in the form of tables. That means rows and columns. Here columns represent attributes. Okay, these columns represent attributes. This column employee SSN, employee ID, employee name, employee email. This column represents attributes. Rows represents individual records of a employee. Now you can ask a question, what are attributes? Attributes are the characteristics of a entity. Now what is an entity? Entity is an independent object here in the real world. Employee is the independent object in the real world. So what are the characteristics of a employee? Employee has a characteristics of employee SSN, employee ID, employee name and employee email. So these characteristics are nothing but attributes. So the attributes are represented in columns, and rows that is the details of the individual employee are represented right in rows, that is records. Now this is the basic. Relational database means your data is stored in the form of tables. Now you need to understand what is a candidate key and what is a primary key. So first of all, here first you need to understand what is a primary key. Primary key is a key that is used to identify your records. Now for example, this is the first record. How we are going to identify your record means through employee SSN. You can add or employee ID. So what is the condition for attribute to become a primary key? Remember, every table should have one primary key. Every table, because to identify the data I need a primary key. Now what is a primary key? Primary key is a key, right, that is different for every rows or every record. That is different, and primary key should not be duplicated. Primary key should be different. Primary key should not be duplicated. Now according to this example, I am going to make employee SSN as my primary key. Now you can ask a question, can you make other attributes as a primary key? Yes, chances are there, but I'm going to make employee SSN as a primary key means SSN is like it's a social security number, right? It is different for every employee. It is like identification number. So this employee SSN is different for every employee. So that's why it is different. The first condition of a primary key, every value should be different and it should not be repeated. As you know that identification number can't be repeated. So I am making employee SSN as a primary key. You can ask why you can't make employee name as a primary key means two different persons with the same name may exist. Okay, that's why I can't make employee name as a primary key, because chances are there the names can be repeated. So that's why I am making employee SSN as a primary key. It is unique for all the records. Now what is a candidate key? Candidate key means attribute that is eligible to become a primary key, but it is not a primary key. Now you can ask a question, which is the attribute that is eligible to become a primary key here? So what is my primary key here? Employee SSN is a primary key, but observe employee ID. Employee ID is also different for every employee here. Again, employee ID is also eligible to become a primary key, but it is not a primary key. It is eligible to become a primary key, but it is not a primary key. So here employee SSN is a primary key, my employee ID is a candidate key. It is eligible to become a primary key, but it is not a primary key. So employee ID can also become a primary key, but it is not a primary key. That's why my employee ID is a candidate key. Employee SSN is a primary key. So these are the basics. Next, only one more basic you need to understand the second normal form. Now, what is a prime attribute and what is a non-prime attribute? So an attribute of a relation schema is a prime attribute if it is a member of any candidate key. That means employee ID is my prime attribute here because it is a member of a candidate key. Now what is a non-prime attribute? An attribute is called a non-prime attribute if it's not a prime attribute, that is, it is not a member of a candidate key. Here employee name, employee email are nothing but non-prime attributes because I am not considering them as a candidate key. Any attribute that is a candidate key can be considered as a prime attribute. Any attributes that are not candidate keys are non-prime attributes. So here employee is eligible to become primary key. Employee ID is eligible to become primary key. That's why it's a candidate key. Employee name and employee email are not eligible to become a primary key because the data can be repeated here. That's why employee name and employee ID are not candidate keys, right? That's why they are considered as a non-prime attribute. Employee name and employee email. Employee ID is eligible to become a primary key. That's why it is a candidate key. It is going to consider it as a prime attribute. Hope you are understanding the concepts. Suppose if you have any doubts, please post your doubts in the comment section. Okay guys, so now I will move to the explanation of second normal form. So to understand what is a second normal form, along with the basics, you need to understand one more concept here, that is functional dependency, fully functional dependency. Now first I will take the definition. Next I will explain with the example, then you are going to understand in a very easy way. See here, now what is fully functional dependency? So x tends to y is fully functionally dependency. That means here this one, yeah, this symbol is tends to, x tends to y. Here you can ask a question, what is x and what is y? X is one attribute, y is one attribute. If x attribute is going to be fully functional dependent on y, so according to this definition, see here, x tends to y is a fully functional dependency is removal of any attribute a from x, means that the dependency does not hold anymore. Don't get confused, I am going to explain with example. See here, so many different definitions are there here, but I am going to explain formal definition. It will make easy for you. So functional dependency means, see, I am going to explain with the example, right? See here, you need to understand what are the prime attributes and what are the non-prime attributes here. Here my prime attributes are SSN and project number. My non-prime attributes are hours, e-name, p-name and project location. This is a table. It is going to store the information about the employee project here. So here, what are my prime attributes? SSN and project number is my prime attribute. Hours, e-name, p-name, p-location are my non-prime attributes. Okay. Now, what is functional dependency? Functional dependency means x is fully functionally fully dependent on y, means, see here my x is what? SSN and project number. Y is what? This hours, e-name, p-name, p-location. Now you can see here, hours is fully functionally dependent on SSN P number. That means if you need to identify hours without SSN and project number, you can't identify it. Suppose, see, if I remove SSN and project number, can you identify how many hours an employee worked? No. To identify how many hours an employee worked in a particular project, you need SSN and project number. If you don't have SSN and project number, you can't identify how many hours that particular employee worked. So here SSN and project number is hours is fully functionally dependent on your primary key SSN and project number. Now you can ask a question. You told primary key should be a single attribute, right? No, it's not a rule that your primary key can be set of two attributes also. That is called as composite primary key here. So here my primary key is a composite primary key. Composite primary key means it is a set of one or more attributes. Here my primary key is what? Project number and SSN. That is prime attribute. Okay. So here my primary key SSN and project number, right, is full. Yes, SSN and project number is my primary key because it's a composite primary key. So according to the functional dependency definition, our attribute is fully dependent on SSN and project number because I can't identify the number of hours that employee worked without SSN and project number. In the same way, the employee name is also fully functionally dependent on SSN because if you don't have SSN information, I can't identify the employee name itself. Getting my point, guys? Please, suppose if you have any doubts, please post your doubts in the comment section. So if SSN is there, I can identify employee name. If SSN is not there, I can't identify employee name. So here employee name is fully dependent on the attribute SSN. That is functional dependency. Hope you are understanding. Now in the same way, project name and project location attributes are fully functionally dependent on project number. Now you can ask a question, why I can't identify project name and project location if I don't have the project number. That's why project location and project name are fully functionally dependent on project number. Hope you are understanding the concept. So sorry. Now what is the functional dependency? So if x tends to y is a fully functional dependency, is removal of any attribute a from x means that the dependency does not hold anymore. So another thing is what? If an attribute depends on an only part of multivalued key, remove it to a separate table. Right? And also another thing, same thing is explained in different definition. A relation schema is in 2NF if every non-prime attribute in relation is not partially dependent on any key of the relation. Okay, hope you understood the fully functional dependency. Okay, now what is the definition of 2NF? A relation is in 2NF if and only if it is in 1NF. That is the first condition. If I want to say a particular table is in the form of 2NF, what is the first condition? First, it should be in 1NF. 1NF, that is the first condition, first normal form. It should be in first normal form. So what is the second condition? Second condition is every non-key attribute is fully dependent on the primary key. So every non-key attribute is fully dependent on the primary key. So if and only if it is in 1NF, and every non-key attribute is fully dependent on the primary key. So see here. So you can see here, SSN and project number is my primary key. I already told you it is my composite primary key. So here hours is fully dependent on SSN and project number. Employee name is fully dependent on SSN. Project name and project location is fully dependent on project number. You know that, right? So condition is what? So fully functional dependency should hold. Every non-prime attribute should fully dependent on the prime attribute. So hour is a non-prime attribute. SSN and project number is my prime attribute. E-name is my non-prime attribute. SSN is my prime attribute. Project name and project location is my non-prime attribute. So project number is my prime attribute. So according to the definition, okay, so every non-key attribute is fully dependent on the primary key. Yes, here every non-attribute is fully dependent on the primary key. If it's a case, I need to divide my table into separate table. That means every functional dependency should be represented as separate table. Here my first functional dependency is what? Ours is fully functionally dependent on SSN and project number. So I am representing that first functional dependency as separate table according to the second normal form. See, you can see here, this is one, this is the first table. I divided my entire table into separate table. So SSN, project number and hours. This is first functional dependency. What is my second functional dependency? Employee name and SSN. See, employee name is fully functionally dependent on SSN. So I am dividing that as a separate table. This is separate table employee 2. Now project location and project name is fully functionally dependent on project number. So I am dividing the entire table as a separate table. So see, project number, project name and project location. So what is the definition here? So first condition is it should be in first normal form. First normal form means every attribute should have the different values. It's very simple. So that is the first condition. Here you should assume that every attribute's values are different here. I have not shown the attribute values here, only showed the attributes, but you should assume that every attribute value of this particular attributes is different here. Yes, you should assume that first NF is satisfied. Now what is the second condition? So second condition is every non-key attribute should be fully functional dependent on the key attribute, that is primary key. Every non-primary key should be fully dependent on the primary key. Yes, every condition holds good here because our is non-primary key is fully functionally dependent on SS and P number, that is primary key. E name is a non-primary key, that is fully functionally dependent on SSN. P name and project location are non-primary key, that is fully dependent on project number, that is primary key. Getting my point? So every condition is holding good. So if it's the case, you need to divide all the functional dependencies into separate tables. See, I divided entire functional dependencies as separate tables. Hope you understood the concept. Suppose if you have any doubts, please post your doubt in the comment section. I'm happy to solve your doubts. So that's it guys. Thank you for watching the video.